Hi everyone, we're going to evaluate the integral of x cubed plus x squared plus 2x plus 1 all divided by x squared plus 1 then times x squared plus 2 dx. So we're going to have to use partial fraction decomposition. We have two irreducible quadratic factors here. So we're going to set this up as, and I'm just going to look at the integrand here. We can set this up, put a linear part on top of the quadratic, like that. And then we have to do the same thing with the second irreducible quadratic. So we want to put some linear term, get all the possible options open for us, x squared plus 2. Now we're going to clear the fractions by multiplying through our left-hand side with our right-hand side. I'll call this your least common denominator. So if you multiply this part by the common denominator, you're just going to be left with the numerator, x cubed plus x squared plus 2x plus 1. And for this side, you just kind of do this cross multiply thing here. So you're going to get a x plus b times x squared plus 2. And then plus cx plus d times x squared plus 1. All right, let's simplify this side here. We're going to keep this, so I'll just put that there. I'll put quotation marks there for now. This is going to give you ax cubed plus bx squared plus 2ax plus 2b. That's foiling that out. And then for this one, we'll get cx cubed plus dx squared plus cx plus d. All right. Now what we want to do is group our coefficients together. So we have x cubed plus x squared plus 2x plus 1. And for my cubes, I'm going to get a plus c times x cubed. And then for my squares, I'm going to get plus b plus d x squared. And then for my x's, I'll get plus 2a plus c times x. And then for my constants, that's just going to be 2b plus d. All right, so let's write out our system of equations and equate coefficients. So for the first equation, this one, we're going to get a plus c equals 1, because you just go over, you can actually cross these out. You get a plus c equals 1. All right, and then for this one, you're going to get b plus d also equals 1. And then for this one, you're going to get 2a plus c equals the 2, because remember, we're just crossing these out. And then for this one, we're going to get 2b plus d equals 1. All right, so I'll just write this as 1, 2, 3, and 4. Now let's subtract 1 from 2. If you subtract 1 from 2, you're going to get a equals 1. So I'm kind of working backwards here. 2a minus a is a. C minus c is 0. And 2 minus 1 is 1. So a is 1. And then if a is 1, then our c has to be 0. Right? Because it has to satisfy this. So now let's do the b's and d's. Let's subtract 2 from 4. So 2b minus b is b. D minus d is 0. And 1 minus 1. So b is going to be 0. If b is 0, that means d has to equal 1. All right, so there's what we're going to fill in. And we're going to substitute them back into this right here. All right, so this is going to give me, let's see, the integral of x divided by x squared plus 1 divided by x squared plus 2 dx. All right, for this one, let's split it up. For example, I'm going to write this as the integral of x divided by x squared plus 1. So if we let u equal x squared plus 1, then we have du equals 2x dx. Or you could say x, no, let me put a dx here, x dx equals 1/2 du. So from that, we can write this as 1/2 times the integral of 1 divided by u du, using my substitutions for u. Now this is going to equal 1/2 times ln of absolute value of u plus c. And then you just substitute back in your u, so you can get 1/2 ln of absolute value of x squared plus 1 plus c. So that's this part. Now this one is your tangent, so let's look at that one. For tangent, it can be, it's really a good idea to know this formula for tangent. So basically we had the integral of 1 divided by x squared plus 2 dx. And so this is the format we have. So basically we let a equal square root of 2. So if a is square root of 2, then when you integrate this, you're going to get the integral of 1 divided by x squared plus square root of 2 squared dx. And that's going to give you 1 divided by, and again, I'm just using this formula, square root of 2 inverse tan of x divided by square root of 2 plus c. Therefore, your final answer is going to be it all put together, and that's going to be your integral. Just put your integral equals 1/2 ln of x squared plus 1 divided by square root of 2 inverse tan of x divided by square root of 2 plus c. And this is your final answer. Thank you. Have a nice day. Bye-bye.